what I will do is I will post this. I have a YouTube channel. I post it there where I keep all my class stuff, and it'll link here. So afterwards, again, anyone who missed class could watch it, or if you want to watch it over, because again, you might find that the auditory way of learning is more beneficial for you. Okay, and so we'll see what way works best. And then there's the notes here, which you actually already have, but I just got them in here. What we will do is once we finish with sort of the story of the statistics, we'll go back and talk. You will talk with your people at your table and go through and complete that part. And those become your notes for then doing the homework. Okay, so there'll be some homework questions, and using your notes each time is going to make it pretty straightforward. Okay, and we'll cycle through there. There's also some additional resources down here, which once we get done, I'll show you, that has like definitions and such, so you'll be able to see. Actually, let me show it to you now. So like, we're going to do 2 sections today just because they're very closely related, and I think we'll do better that way. So there's a summary which just says what we did, right? But there's frequently asked questions. So these are types of things we're going to talk about. And you'll have this as a resource when you're filling out your documents with your notes. And there's these definitions here. So these are a good place to come back and put those. But again, by the time you've done your notes, you'll have all of these in your notes as well. Okay. There's a podcast that was generated from the notes, and I hear it's pretty good. This was from our other professor, Mr. Gilmore. I haven't watched those yet. And then there's also chapter videos where Mr. Gilmore goes through sort of the same type of thing. So if you ever need these, or maybe you want to get ahead, you'll be able to see those at any time. Okay. And what he does is he takes the actual notes and does his lecture or his story off of those notes and kind of fills them in. So he produced the notes, he does the notes. So you can also watch those to kind of see what his answers were. Again, as we go through this, our answers might be a little different, but what we want to focus on is why we're answering something a certain way. And the reason why we answer it that way might be correct, whereas the book or something gives a different answer because they had a different assumption. And there's one of those in here today. Okay, so are we ready for the story of statistics? Okay, and again, you'll see that this is based on the textbook we have in my math lab, which is what Mr. Gilmore based the notes that he came up with. And again, remember, I'm not plagiarizing. I'm not saying, oh, I made these notes. I didn't. Mr. Gilmore did, and he shared them with me. So they're all based off of this, and you're going to see this PowerPoint was made by the company, so it'll look very similar to what you're working on. So we're first going to go take a look at some objectives. This is just sort of a roadmap of where we're going to go today. So we'll see what statistics is. We've talked a little bit about it, but we'll talk more. We're going to see, again, you'll see those words in bold. We're going to talk about a population and a sample. How are they different? How are they similar? And then descriptive and inferential statistics. Again, we've broached those a little bit, but today we'll actually get into the definitions. And when we get definitions, I'm not going to ever test you on what's the definition of this word, but I want you to be able to use that word. When you see that word, you kind of know what it's talking about and you know how to use it. Okay. So what is data? And we talked a little bit about it, but it is information that comes from watching things, observing, measuring, counting, and seeing, and also responses, getting people's opinions. How many people believe this? How many people believe that? So those type of things are what we call data, any kind of number. And again, we'll see it. Not every piece of data is actually a number. Stuff like, here's for someone from the arts, 7 out of 10 people, Americans believe arts unify their community. So that's a piece of data. So they went and asked people's opinions. 7 out of 10 said that. Actually, they probably asked more than 10 people, but they'll report it that way. Okay. 2 in 5 Americans have changed their opinion based on art. So again, pieces of data. They had to go ask people, has art changed your life? Yes or no. So 2 out of 5 said yes. And then stuff like 21%. So we sometimes see statistics reported in a percentage way. And so they went and got a bunch of data, and 21%, so that's 21 out of 100, 8 to 11-year-olds have a social media profile. Okay, so they get these from somewhere. So what is statistics? It's a science of analyzing data, collecting data, and applying it to make decisions. So that's the key part. Actually, all of mathematics, what we should be doing it for is to help us make good decisions. Now we'll do the calculations. It gives us some evidence. We also might have some other evidence, like how we feel, our emotions towards something. We bring that into the decision process as well. But mathematics, especially statistics, is here for us to get something that will say, maybe I should do this or that. Sometimes we don't always listen to what the statistics say, because we see, I think my gut feeling is we should do something different. And that's okay. But just using all of this for decision making. And if we bring all of this in, hopefully we can make better decisions. And again, we can be more skillful, right? Skillful gets us to what we want to have happen. And sometimes it's unskillful to just rely on the data, because we also have to use our experience. A note on this, though, is sometimes we use the word statistics to mean the data. So you will see it used both ways. Statistics as a course of study, as a methods, but also as the data itself. So don't get too confused. Sometimes which way, just by the context, you should be able to pick out the way they're using it. Are they referring to the data or to the science of collecting? Okay, so here we come with our first big definition. Is whenever we're looking at data sets, they come from 2 different groups, and they're related. So first of all, one group we talk about is the population. And the population is everything we're interested in. So it might be, we want to know what high school students in America believe about something. So that's, a lot of people, right? It's all of them. That's our population. And then we want to know measurements and opinions and stuff, but anyone want to go talk to every high school student in America? That might take a while, right? They might be out of high school by the time we get done. So what we do instead is we get a sample. So we can kind of see from here, we took, let's get this lady's opinion. Let's get this lady's opinion. Let this get this guy's opinion. So we took a sample from the population. We went in and took them out. A little bit later, we're going to talk about how to do that in a way that we get what we call a representative sample, that the sample could be very much like the population. If we just pick 3 people out of there, it could be likely that we don't get a representation of the sample, but we get a certain grouping, right? So the importance with statistics is picking that sample in a way that we can then, whatever we get from that sample, we could relate back to the population. And that's a key part of what we're going to be doing, but not today, okay? So the thing we want to just understand is there's a difference between a population and the sample. The sample is always smaller, right? Because we're just taking some of them, so that we could go talk to those 3 people, get their opinions, be done with our project, right? We don't have to go talk to the whole USA, but we might have to talk to a lot. So, okay. So here's a way to identify. We want you to just do this, and as you go back to your notes, you'll see it's in there, but you'll be able to pick this out. So we've got a recent survey. So that means a survey is something we send out to get people's opinions. 834 employees in the United States were asked if their jobs were highly stressful. Of the 834 respondents, 570 said yes. So now your goal, let's identify who the population is and who the sample is. Does anyone have an idea? What would you say the population is? You fell into the same trap that I did when I first read this. 835 were what? They were asked their opinions, but the survey is actually wanting what probably all workers in the United States. So they only asked the 834. So the 834 are the sample. All workers in America would be the population of interest. So, and you'll see another one that I differ from the book when we go through it, but it's easy to do that. Okay, so usually if there's a number involved in those that were tested, that's your sample. So the sample is usually easier to identify than the population. The population is going to include all of them. And what they did to us is they gave us two numbers. So you say, okay, 517 is the sample, and no, 517 are ones who said yes. So that's data, right? That's data from the sample. Those 517 were in the sample. Okay. Good. Does that make sense? So it's a smaller group, and we go through there. And they're going to spell it out a little bit more for us. Population consists of all responses of all employees in the U.S., although we didn't ask them all because we just don't have the funding for that, right? We only went and asked 834. That's our sample. Okay. And then there's a subset from within that sample. Some said, yes, my job's very stressful. Others said no. And so we were told 517 said yes. Now they're making an assumption that everybody else must have said no, but have you ever taken a survey and maybe not even answered the question? I don't want to answer that one. I do, so we don't know necessarily just because 517 said yes that the rest said no, but sometimes we can jump to that conclusion. Okay, and again, what they're showing is this box is all the employees in the U.S. The sample is just a subset. Okay. Two other words we're going to pick up is that there are words involved with the population and different words that are involved with the sample. So whenever we talk about data, a numerical description of a population, we call that a parameter. So P for P, population has a parameter. That's the kind of data there. Okay. When we're talking about a sample, the sample is the piece of data is we call that a statistic. So in that last example, the 517 who said yes, that's a statistic because that came from the sample. If we relate it back to the population, then it would become a parameter. Okay, so it's just you're going to see these two words, and you just have to know if they say something about a parameter, who does that apply to? The population, all of them. If they say we have a statistic, who did that come from? Just the sample. And so when you know that's coming from a sample, you've got to start thinking, did they choose the sample correctly? It might be good information or it might not be. So in statistics, you got to do everything right to have information that will help you make good decisions. And if anywhere along the step, like they didn't get a good sample, statistics not going to really be much that we could use. But if we do everything right, then it could be helpful. But a parameter, since it comes from the population, will always represent sort of what's going on. Okay, so here's an example. Decide whether each number describes a population or parameter. And again, in this one of these I'm going to come up with, I disagree with what they came up with. So, and some of these are in your notes. Some, I think this one's maybe not. Sometimes the numbers are changed a little different because I think they updated the slides since they did these. But you'll see, you'll be able to get it. So in the United States, a survey of about 9,400 individuals aged 15 and over found that such individuals spend an average of 519 hours per day engaged in leisure and sports activities. So is this information, is it a parameter or is it a statistic? Why is it a statistic? Excellent. Exactly. That's all we do. It's coming from a group, a smaller group, Not all they didn't get everybody in the U.S. If it, so that would make it a parameter. It was a smaller group. So it's information. Now we might apply it to the population or assume that the population would have a similar average, but it's not always true. So good. This would be a statistic. I'll just circle the statistic. Okay. Make sense? Okay. And because the average day is based on a subset of the population, it's a sample set. Simple as that. Good. Now this one. Okay. I'm going to go with how I think of it, but so decide whether the numerical value describes a population parameter or a sample statistic. The freshman class at a university has an average SAT math score of 517. So is this number, is that a parameter or a statistic? Statistic, why? It's from just the freshmen, right? That's how I saw it. We're going to see the textbook sees it differently. So I look at it. It's okay that it's an average. So yeah, they would have actually collected the scores and average it, but it's a calculation based on just the freshmen. Now, I would say a university is made up of freshmen, sophomore, juniors, and seniors. That's a whole school. That would be the population. However, if I told you that this study, it's only studying freshmen at a university, the fact that this comes from, it's a sort of, it doesn't say it directly, but assuming that's all the freshman class, would that change your thoughts on this? Yeah, if because then that says that the freshman class is our population. That's how the textbook is reading it. I didn't read it that way because they didn't say it specifically. I said, well, that's just part of the university, right? So we'll go to their answer. Because the average math score is based on the entire freshman class, it is a population parameter. Again, I don't feel they did a good job in letting me know that the freshman class was their population, because they're talking about a university. As soon as they did that, I said, well, university is our population, which means there's more than just the freshman class. So the other thing I want you to be able to do is, as you go through this, challenge something. Just because the book says this is the answer, or just because I say this is the answer, you might say, well, I thought it was this because freshman is not the population. And I could look at this, well, you're right, I didn't write it up right. So be willing to challenge that and come with your explanations. Okay. And this even happens at the, I've looked at stuff that has been done like at the legislature, and they print everything up, and there's misunderstandings that they're using that, are lawmakers, and they're basing laws based on some of this stuff. And you're going, come back and take a statistics class so you get it right, but or define things better. How about in a random check of several hundred retail stores, the Food and Drug Administration found that 34% of the stores were not storing fish at the proper temperature. Is that a statistic or a parameter? Statistic, why? Good, a random check. So they checked a few of them. We know we're dealing with a sample. Okay, so you see how statistics is actually more like maybe an English class of understanding the language. And sometimes they put enough in there, sometimes they don't. Yeah, based on a subset, it's a statistic. So we'll just pick that up. Now, when we talk about statistics, there are two types of statistics that we're going to look at. One is descriptive statistics, which gives us a description of a group. Okay, maybe your height and your age and your eye color, something like that, that we can kind of get a summary of a group. The other type of data that we are interested in is inferential statistics, that we can use it then to make a prediction possibly about the future, or to make some conclusion about the population. Okay, and sometimes a statistic could be a little bit of both. if we do it in a way, and we're going to see some examples, but we could use it just to sort of describe it. The average is this. That sort of describes it, doesn't it? But then if we say that that average of that sample is very similar to what the population should be, then it's a inference. So we can use a piece of data in both ways as we do things. Going from the sample, saying it represents the population. But again, to do that, we need a little bit more evidence. We need to show not only did we do the calculations, everybody, this many people said yes, and that's a percentage, we also have to show we chose the sample in a way that this sample represents the population. So more evidence is needed with inferential statistics. So again, here's a study. We won't have to read all of this, but the question is this what's being given to us? Is it inferential statistics or is it descriptive? So study of 1,502 US adults found that 18% of adults from the households earning less than 30,000 annually do not use the internet. 18%. So is that a descriptive? Why? Okay, so we've got some data. And so there's our 18%. And again, they've got it broken up by categories of how much they make. And it describes something, right? It's telling us 18% of these folks, it's just telling us. How could we turn this into an inferential statistic? Yes. Yes, they did. And then if we say our sample is good, and so the population must be 18%, now it's a inferential statistic. Okay, so see how a descriptive statistic can easily become inferential as long as we link the sample to the population somehow, that the sample is representative of that population. Okay. So in this one, we're wanting to identify the population and the sample, and then is it descriptive or inferential? So a study of 1,000 US 401k retirement plan participants found that the percentage who do not know how many years their retirement savings might last is 32%. So who would be the population in this? Population. Retirement plan holders in the US, right? Good. So that's all the retirement plan holders, participants, right? And so the way to do it is so they gave us a number. So that number must refer to what? The sample. And so the population is just all those, more than the 1,000. It's everybody else. So that's kind of the way. Usually what I do is I identify the sample because that's easier. And then I know the population as well. Just take the number off and it's everybody. Good, good. So is this statistic that was found, I don't know, is it a statistic or is it a parameter? This number that was found, is it descriptive or is it inferential? What would make it inferential? What does it need to be if it's going to be inferential? It can come from a sample, but it has to link to the population. Okay, so that number can be inferential statistics as long as we say that we have a representative sample and it also reflects the population. Otherwise, it's just a descriptive statistic because it was taken from that sample. Okay, which would make it a statistic. If we link it, then it also makes it a parameter, right? If we link it to the population. So again, getting used to these definitions and using them. Okay, so that actually is the end of section 1.1. What we're going to do is we're going to dive into section 1.2 because I think that will put everything together. And then in 1.3, we're actually going to talk about how to set up a study, how to do the research, which will involve selecting the sample. But this next step is kind of important too because this talks about data. So we're going to talk about Two types of data. And notice the difficulty we're going to face here is that both the types of data start with Q, qualitative and quantitative. And sometimes it's hard to hear which one is which, right? But one has an L and one has an N. So we'll talk about that. And then we're going to look at the data actually itself also has 4 different types of classifications. And depending upon how we classify the data will determine how we can use that data. Okay, so qualitative, quality, right? Characteristics. These are non-numerical data. So not numbers. Well, we'll talk about non-numerical entries such as what is your major? You don't say I've got major number 3. No, I'm an engineering major. I'm a art major. I'm this. You know, so it's a descriptive, it's qualitative, it's a category. Okay. Place of birth. Now that's not a number. It's a city. It's a name of a city or state or country or something. Your eye color. Colors are not numbers, right? Brown, black, blue, green, such as that. The thing we find with qualitative data, and again, focus on this first part, sort of quality, is that we can't do any math with it, right? You can't take brown eyes plus blue eyes and get in. You know, it's maybe if you're artistic, you can figure out what that would be. But numerically, we can't do it. We can't do math with qualitative data. However, a lot of studies, the qualitative data is very important. You know, the words you use to describe your opinions and stuff. So there's a whole field of how to do qualitative studies. And that's what my research was in. And it's more of this sort of story. Is that mine? Sorry, that's a newer phone. I don't know how to turn the ringer off, but I use it for my hotspot right now. So, okay, so qualitative, that's one type. The next type is quantitative. Quantity. I would like to use this number instead of what I try to do in this is I say this is going to be an amount. You know, it really is a number of things. So, I mean, the numbers are involved here. So numerical measurements or counts, how many, we count them, and or we measure something, how wide is this desk? We use a ruler, things such as age, the weight of a letter, the temperature, numbers, right? And we can do things with these. We can get the average temperature. We see it all the time. We add them together, divide by however many are, and that's a whole part of statistics we'll be doing, the numerical part. Okay. We won't get as much into the qualitative part, but we will use parts of it. Okay. I have a question for you that can be most difficult. If this is my phone number, which it's not, but it's a phone number, we'll say, is that qualitative or quantitative? It's what? It's numbers, but can we add my phone number to your phone number and get anything of value? No. It's really qualitative. Those digits, even so, this is where we can be fooled, are really labels or names. It's a name. If you type that in, that gets to this person, you know, so just as if I put it as a name. So there's ones that can masquerade. So I say qualitative data is not numerical, although sometimes the tricky ones, it uses numbers, but it uses them in a way where it's really a label or a name. Okay, so phone numbers, those are actually qualitative data. And we're going to see it a little bit more detail because now we're going to get into the 4 types of data and get there. Now, this was not in your notes but it was, and it might be covered in another section, but I thought it fit really well here. When we have quantitative data, there's 2 types. The first is called discrete, and that means that there is only a certain number. So like if number of people in a room, you have 20 people, 30 people, 25 people, but not 25.5 and not 25.25. So discrete data is a specific count. Now, shoe sizes, it doesn't mean you can't have decimals. You can go get a size 10 and a half, 10.5, but you can't get a 10.25. At least I haven't seen a place that makes a 10.25 shoe, right? So shoe sizes are discrete as well. Okay, so there's a number of things. It's just a way you would count them, or there's only particular values. So if we have discrete, what would be, which are only particular values, what do you think would be the other type of data? Non-discrete. Okay, that's a good way to do it. Or you could call it continuous. So non-discrete is continuous. Good call. And continuous can take on any value. So it's kind of like whenever we measure something, right? We can get as accurate as we can as our measuring devices. We bring a microscope, we can maybe get even more accurate. So we can add some more decimals on there. So discrete can take on multiple values. The best way I have of describing this, anyone into music? Any musicians? Okay, I used to play the violin in high school. When I got done with that, I didn't play for a while, so then I picked up the mandolin. And the difference between those two, here's a guitar, is if you have frets on the guitar, that's discrete, right? You put your finger down, you get a note. If you have a fretless guitar, you've got to get your finger in just the right place because it can be in many different places and be close but not quite right. So a fretless guitar is continuous, harder to play. So the violin was harder to play. You had to get your finger right in the right spot. Mandolin has frets, so it's a lot easier. So discrete versus continuous. Does that kind of help the difference? Right? We can do any value in between. Okay, we're almost there. We've got this data table. We've got sports and we got head injuries treated. Which one of these is qualitative and which one is quantitative? Qualitative, quantitative. Very good, qualitative, because it's non-numerical, right? These are labels. They're non-numerical. You can't add football and gymnastics together, or you can't do any math with them. So that's definitely qualitative. Over here, we do have numbers, and it would make sense if we might, what's the total in these two sports? We could add those numbers together. Those are definitely quantitative amounts. Okay, good. And then what we're going to focus on is out of the four types of data, one is only qualitative, one could be either or, and then the last two are strictly quantitative. But there's even with numbers, there's a difference in how we treat them. Okay, so now this is what's called levels of measurement. What kind of data we have? The first type is what we call nominal. Nominal is strictly qualitative data. So that was like the sports names. That's nominal. You can't. So it's qualitative only. It's categorizing things with names, but there's no mathematical computations can be made. You can't put them in any particular order. I mean, I suppose you could put in alphabetical order, but there's not really a first, second, third sport in this case. So they're not put in order. So that's nominal. So that's, again, one vocabulary word we're going to want to use. And so when you see that, if they tell you they have nominal data, you know that all you can do is these are categories, these are names. Okay? How we doing? Okay. Next level is ordinal. Now, ordinal, and again, some of these are, I don't know where they get these words. Sometimes they get them from like Latin, some other language. Ordinal data can be qualitative or quantitative, can be either, but what makes it different than nominal is you can put it in order. So there is a ranking somehow, either implied or stated. So we'll look at some examples, but the big thing is these come in order of somehow. They're ranked. But the thing is, the differences between the entries, even if they're quantitative, if you were to subtract them, those differences are not important. Okay. And we'll see, again, by looking at examples, ones that are important, ones that's not. So of these two, which one is ordinal? Which one is nominal? Someone new want to? Nominal. Why? They're all different genres. There's really no order. I mean, you might have your favorite. You could probably maybe put them in order of your favorites, but other than that, there's no specific order to the list. Good. How about number one, though? It's ordinal because order. Maybe that's where the word ordinal comes from. Order, right? That matches up. And it's really the same thing, but there's an order because they took a survey, and the survey found the fastest growing jobs, 5 U.S. occupations with the most job growth. So this one would be ordinal, and this one nominal. Yes, sir. Right. Yeah. If they give us the top 5, if they give us the ranking, now if they just say these are all in the top 5, at that stage they're still just nominal because we don't know what the order is. But if they give us the order, then that's what's making it ordinal. Okay. So far, so good. We're almost there. A couple more slides, and how long we go till 51? So it'll be enough for me to introduce you to the homework setting, and then tomorrow we'll definitely get into doing the homework and see where we go from there. Okay, see what our pacing is. Okay. Yeah. So they give it to us, and the textbook agrees with us. Okay. Okay. We ready? These are the two most important ones because these are the types of data we'll be doing calculations with. Okay. And we have to make a distinction between these two, because here's what can happen with statistics. If you use one of these for a different type of statistic, you get nothing that's even of importance. So two quantitative, I have to say those, amount type data, right? These are just numericals. So there is something called an interval level, and there's something called a ratio level. So let's see the difference between these two. They're both quantitative data. Interval data can be ordered, so put from smallest, because it is numbers, right? You can put it from smallest to largest. You can subtract the data and get something of value, that one is bigger than the other or something by so much. So we can use differences. But the zero does, this is important, this is a big difference, it does not imply none. So this is stuff like a temperature. 0 doesn't mean no degrees, it means it is actually a particular temperature, right? And it's on that scale. And you could have negative temperatures as well. So temperatures, the 0 is not none. So that would be interval type data, mostly, okay? So the 0 in interval data is part of a scale. It's a measure, so the measurements like that. Ratio level, we're going to see, is different. First, it's very similar, except 0 implies none. So it's more for things that are like counts of something, that if you have 0 in this case, that there's none of the quality. Okay, so that's one distinguishing factor. And you can always do this in this data. If I put in 0, does it mean that I don't have anything, or does it mean that I got a particular measurement? Okay. The ratio of two data values can be formed. So that's why it's called ratio. You can take a fraction, you can take two numbers and divide them. And then what you get is you're able to express them as a multiple. Like this data is twice as big or 3 times as big as that. The population of California is 5 times as large as some other state, something like that. So we can actually divide them. You can't do that with interval data. And Let's look at some examples of why that is. Oh, I should have took that slide out. It's just a repeat of what we just went over, but I wanted it on one slide. So here's two pieces of data. They're both numerical, right? They're numbers. One is the years that the New York Yankees won the World Series, which is a lot. The other one over here is home run totals by team in 2020. So which of these sets of data is interval and which is ratio? And why? Why? It's ordered. If we had the year 0 on here, would that mean that there was no, what would that mean? It would just be a year. I don't know if they were playing baseball when in year 0, but probably no New York Yankees then. But yeah, it would be just a year. It's not something that means none. Good. Would it make any sense to take 1923 divided by 1927? With that, no, that number means nothing. So I can't do a ratio with it. It's meaningless. I could subtract them and say that it took 4 years for them to get the next one. So that's got some meaning, but I can't do a ratio. How about over here with the home run totals? What kind of measurement is that? It's a ratio. Why? Good. Look, so 0 is 0. If it's 0, you didn't hit any, right? Yeah, it's not just a measure. It's, yeah, good. So there's implied, so 0 means none. That's one reason. What's another reason that this is ratio and not interval? Could I take 77 divided by 59? Would that have any meaning? It would. It would mean that the Baltimore hit that 1.5 more home runs or something, whatever that number ends up being, right? So it does have meaning. I can divide them, and then I've got multiples. Cool. Gosh. Well, good, because I'm almost done. Here's our answers. And we were same as the book. And then there's just going to be some summaries. But what we're going to do is tomorrow we'll finish up taking notes with your notes, and then we'll introduce you to the My Math Lab homework and start into that. How was that for the first day of real instruction? Okay, we'll keep it going. Good notes. Good.
I think it's better. We're gonna do this again, but I'm gonna write tomorrow, right?
Yeah, yeah.
I think it's better for me like that. I work
Yeah, so it's kind of we'll look at it at least 2 times, and then you go through the homework and you look at it again, and that's how it sinks in. You look at things 3 times, and before exams we'll review again, and yeah, we're gonna.